Hello, Matt here from chemistrystudent.com. In this video, we're going to look at optical isomerism. We're going to talk about what optical isomerism actually is, what optical isomers and enantiomers are, how optical isomerism arises, and explain the term chiral carbon. Before we talk in detail about optical isomers, there are a couple of essential ideas you need to be comfortable with. Isomers are molecules with the same molecular formula and a different structure. Stereoisomers are a type of isomer where the molecules have the same structural formula but differ in how their atoms are arranged in three-dimensional space. Carbon atoms can form 4 single covalent bonds with other atoms in a tetrahedral arrangement, with bond angles of 109.5 degrees between all 4 bonds. Recap done? Let's go. Optical isomers, also called enantiomers, are stereoisomers that are non-superimposable mirror images of one another that rotate plane polarized light in opposite directions. That sounds horrible and confusing. Let's break it down. The term non-superimposable means that the two molecules cannot be perfectly overlaid on one another. In other words, you can't place one on top of the other and perfectly block it out. A bit like a left and right hand. You can place the right hand on top of the left, but the thumb and fingers don't rest on top of each other from each hand. They are non-superimposable. 2 left hands or 2 right hands, however, could be placed on top of each other, matching up perfectly. They would be superimposable. The mirror image part just means they are inverted, like reflections of one another. A mirror image is an inversion of the object making the image. Again, if we look at a left hand, the mirror image of a left hand gives the same shape and arrangement of a right hand. We can describe left and right hands, therefore, as mirror images of one another, even if they aren't literally mirror images. Plane polarized light is light that's been filtered so it oscillates in just one direction. Imagine unpolarized light as waves moving in all directions, while plane polarized light is like a sheet of light waves moving in only one plane. Enantiomers, or optical isomers, rotate plane polarized light in opposite directions. When plane polarized light passes through one enantiomer, the light's direction of oscillation is rotated one way. Through the other enantiomer, it rotates the opposite way, often shown as positive and negative. This rotation occurs because of the arrangement of bonded atoms and groups in the isomers, specifically because of something called chirality. Chirality occurs when a carbon atom is bonded to 4 different atoms or groups, making it a chiral carbon. This idea of chirality is really important because if a carbon atom is chiral, there are 2 different ways the groups bonded to it can be arranged. This means 2 different possible stereoisomers can exist, and surprise, surprise, the 2 different arrangements rotate plane polarized light in opposite directions. Hence, we describe these stereoisomers as optical isomers, and the molecules are called enantiomers. It is also the chirality that makes the enantiomers non-superimposable mirror images of each other. For example, in these 2 models, the central carbon atom, black ball, is bonded to the same groups. However, they are mirror images of each other, just like a pair of left and right hands. Now, as a result, you can't superimpose one molecule on top of the other, no matter how you rotate or spin them in space. A mixture that contains 2 enantiomers in equal quantities or concentrations is called a racemic mixture. Racemic mixtures give no overall rotation of plane polarized light. This is because the rotation caused by one isomer is cancelled out by the rotation of the other. And if both isomers are present in equal amounts, the overall rotation of each should be the same. So, to summarize, Optical isomers, also called enantiomers, are stereoisomers that are non-superimposable mirror images of one another that rotate plane polarized light in opposite directions. Optical isomerism arises due to chirality. Carbons bonded to 4 different groups are called chiral, and the molecule they are in has chirality. A mixture that contains 2 optical isomers in equal quantities is called a racemic mixture. Racemic mixtures don't rotate plane polarized light. I hope you found this video useful. Please check out other relevant videos in the links given in the description below, and visit chemistrystudent.com for free notes and revision materials.